Hi everyone, Ewan here, and how are you doing today? Hope your day is going well. So today I just wanted to follow up on the last two videos. If you haven't seen them, then I would recommend it. I'll just put them in the links in the comments. And last two videos we're going over how to solve to find the resultant force and its direction. So for 2D forces. And to do that we used algebra, so the algebraic method with the cosine law and the sine law. So if you don't know what that is, I just recommend watching it after this episode because they're not linked, so it's okay. And so this time we're going to use components. So we're going to break down each force into the x and the y components, and then we'll put these together and we'll get the components for the resultant force, and then we can find the angle with that as well. I'll just show you. And fantastic. Right, so I have two examples here, and the first one, as usual, you can have a look at the question, pause the video, trying to solve it yourself, and then come back and I'll just solve it now. So we have two forces, F1, F2, and actually these are the same examples from last tutorial. We're just going to use the different methods. So to break down each force into two components, so we have the x and the y component. These are of course perpendicular. And so for the 900 Newton force on the right, we'll have a component going down. This is the y component and this is the x component with an angle here, 35 degrees. Now, so these are perpendicular, and this is the x and this is the y. Now, let's try this. So, for example, the sinus of 35 degrees is going to be equal to the opposite, so which is x, the x component, over the hypotenuse, which is 900. And now we're interested in f1x, so it's just going to be, imagine this is over 1, so it's simply going to be 900 multiplied by sine 35 degrees divided by 1. There we go, the cross multiplication rule. So anyway, using this rule, we can simplify the coordinates for f1x, and that would be just what I did here. That would be sine 35 degrees multiplied by 900, and f1y is simply cosine 900 cosine 35 degrees. So far so good. Now we're going to do the exact same thing but with 600. So there's a component in the y, component in the x, exact same thing. However, the angle here is different. Here in the question it does tell us that f1 and f2 are perpendicular. So we can assume that this is 90 degrees. Knowing that this angle is 35 degrees, this angle then is 55 degrees. This angle here, sorry, just put an arrow. This angle here is 55 degrees. Now the exact same thing we're going to do. So f2x is equal to 600 sine 55 degrees, and f2y is equal to 600 cosine 55 degrees. Fantastic. Now that we have all four components, we are going to put each component we're going to add the components in the same direction. So down here on the left, we're going to go the sum of the forces in the x direction. So we've decided here that if a force points to the right, then it's positive, and if the force goes up, it's positive as well. So anything on the opposite would be negative. So in the x, we have for the 900 f1, it's pointing to the right. We'll go like this. So this is positive. We'll just go right ahead and write 900 sine 35. But then for 600, that the x force would be to the left. So we go minus 600 sine 35. Fantastic, and we'll just get an answer for that. And then the sum of the forces in the y direction, same kind of thinking, although both of these forces will go down, so I'll put minus. And we'll just go ahead, and so that would be minus 900 cosine 35 minus 600 cosine 35. Now these answers are this is quite a small answer, which means that it will go slightly to the right, and this answer is negative, and it will go down by quite a bit, 0.38 newtons. Perfect. Now this means if we make a small drawing up here in the middle, that the resultant force is going to go, the two components. We'll want the direction with respect to the horizontal. So we'll have the component of x, which is quite small compared to the component of y. Actually, I'll make it easier for us, and I'll just pop it on this side. And then we'll have the resultant force go like this. And we want the angle, so this is fx, this is fy, and this is our resultant. And the angle we're looking for, the direction with respect to the horizontal, would be this angle here. Let's call it alpha. So r, pop it down here, r is simply, if we use the Pythagoras theorem, is going to be fx squared plus fy squared. And this is simply going to be 24.73 squared, and I put a plus here because even though fy is negative, it will become positive because we're squaring it, so it doesn't really matter. And this will give us 1081, yes, 0.7 newtons. Fantastic. And now for the angle, we know fx and fy. We also know r, but just to be on the safe side, we're going to use the components to find alpha and just leave r out of it, because if we made a mistake in calculating r and we use r again to find alpha, then obviously we're going to make an error in both calculations. So we're going to do fx and fy. So what links, if we use this angle, the opposite side with the adjacent side? That the answer is the tangent. So if we do the tangent of alpha is going to give us the opposite, which is fy, over the adjacent, which is fx. And now we want alpha, so alpha is equal to tan inverse of the same again, fy over fx. And so alpha is simply equal to 88.7 degrees. And there we go. So this angle represents the angle between the resultant force and the horizontal axis. So there you go, that's for question 1. If you have any questions regarding this, you can just pop them in the comments and I'll try my best at answering them. And if this video is helpful so far, I would appreciate it if you would leave a like and subscribe, and also maybe share it to your friends if you think this would benefit them. So anyway, let's make it to question 2. So this one, it's a relatively same question where the forces are perpendicular to each other, but I will show you in the next episode when they aren't. I'm just going to make it slightly more complicated. So same again, the exact same procedure. We're going to find the forces for 6 kilonewton, and it has two components with a 40-degree angle. So let's call this F1 y, this is y, and this is f1 x. So f1 x is equal to 6 kilonewton cosine, because it's the adjacent corner, so 6 cosine 40 degrees, and f1y is equal to 6 sine 40 degrees, because it's the opposite to the angle. Fantastic. Now we are looking for the 4 kilonewton, f2. So same thing again, we're going to have f2x over here, and then going down we have f2y. So f2x, and actually the angle here, so we've been told in the question that f1 and f2 are perpendicular to each other, then this angle is simply 90 minus 40, which is 50 degrees. So if we know that this angle is 50 degrees, f2x is going to be 4 cosine 50 degrees, and f2y is going to be equal to 4 sine 50 degrees. Perfect. Next step, just like the previous question, we are going to calculate them for the sum of the forces in the x and the y direction. So sum of forces in the x direction, both forces are going to the right, so they will both be positive, as just like the previous question. Let's just write this here, y and x. You can change this as you'd like. You can make it down, you can make it up, it doesn't really matter, as the result will be the same. So fx, it's simply going to be 6 cosine 40 degrees plus 4 cosine 50 degrees, and we have some of f in the y direction, which is going to be, so here for the 6 kilonewton force, f1, fy is going to go up, so it's going to be positive, but for f2, fy is going to go down, it's going to be negative. So it's going to be 6 sine 40 degrees minus 4 sine 50 degrees. There we go. And so these two answers are going to give us 7.17 kilonewton, and this is going to give us 0.79 kilonewton. Perfect. So if we do our small drawing again, this time we want the direction with respect to the vertical axis. So this means that our resultant, if fx is positive, then it's going to go to the right, and if fy is positive, then it's going to go up slightly as well. So it's going to end up looking like this. So that's fx, and that is fy. Actually, let me draw that out better so it's going to make it easier for us. This is fy, this is fx. I'm being silly. This is fy, this is fx, and this is going to be our resultant force, r. There we go, sorry about that. And this is the angle we're going to try and find, which is alpha between the resultant and the vertical. So just like last time, r is, if we use the Pythagoras, it's going to be 7.17 squared plus 0.79 squared. Here we go, which is going to give us 7.21 kilonewtons. And for alpha, pop in the corner here, same as before, except that this time we want, let me just pop that here, so same again, tan alpha is equal to the opposite, which is fx, over the adjacent, which is fy, meaning that alpha equals tan inverse of fx over fy, and this gives us an alpha equal to 83.7 degrees. And there you go. These are the two answers. Same again, any questions, you can pop them in the comments and I'll have a look. And I hope you really enjoyed this video. I will upload 2 more examples in the next video, a bit more challenging examples. And hopefully this all makes sense to you, and that this video has been helpful. If it has, please consider subscribing and liking the video and sharing it with anyone who you think will benefit from it. Anyway, thank you for watching, and I'll see you next time. Cheers.